Okay. So ultimately, well, at this point, we seem to be correctly parsing our rooms, correct? Oh. So meaty. Let's see. You want all of Json Parser?
Yeah.
Just copy the code in there.
Can you see something too, please?
I'm going to be giving you all the code. Are you going to use it during class today? So you'll get the whole zipped package. All right. Now, ultimately, what we need to be able to do is we need to now parse this stuff, which we're doing, but actually turn it into rooms, a cave with rooms and treasures and stuff like that, right? So we need to now create our objects in such a way that we are able to build a cave that's empty, add a room to it, add a room to those rooms, add treasures to rooms, that kind of stuff. Okay? So we're going to go back and we're going to add some additional constructors. I think last time I mentioned something that would be similar to polymorphism. We have more than one constructor that does something different, takes a different number of parameters, something like that. So we're going to go into cave initially. Right now, we have a constructor for cave that takes a number of rooms, correct? And this guy goes through and it tries to generate rooms over and over and over and over again until it gets the right number of rooms. Well, in this particular case, we're defining what our cave is ahead of time. So given that, we're going to create a second constructor for cave, and this guy's going to take no parameters. Okay? And we'll go ahead and do some of the initial setup stuff, like completed equals equal to false, even though for your assignment, you didn't even have to have it be completed. It could just crash, that's fine. Okay? And we're going to set entrance equal to false, because there is, to null. Because we do not have an entrance to this cave yet. This is a blank cave, correct? So this will create a blank cave that literally has no entrance. Now, we need to have some methods for setting the entrance, things like that. So we'll say public void set entrance set entrance will take a room R, and we'll set entrance to whatever that room is. Okay? That's all we need to do at the cave level. And just to kind of show you where we're going with this, I'm going to go back into our Json parser. Json parser has something called parse cave. Well, parse cave ultimately is going to return a cave. That's what parse cave does. It builds a cave object. We also have a method called parse room. What's parse room going to do? It's ultimately going to return a room. So inside of parse cave, the very first thing we're going to do is we're going to create a cave. C is equal to a new cave. That is our blank cave. Okay? Down here, when we call parse room, and we know that this will always be parse room, correct? We just happen to know that's going to be the case. We don't even need this if statement or whatever, but doesn't matter. We're going to create a room variable called the entrance. We'll start that off as null. And we're going to say the entrance is equal to whatever is returned by this initial call to parse room. And finally, we'll say C dot set entrance to the entrance. We will add that room, the room that was built up from parsing that entire JSON, as the entrance to the cave. Because notice, if we look back at our code here, here's our cave. Everything inside that JSON represents the one room that is the entrance. Does that make sense? So if our parse room works, all this other crap will have been enveloped into the room object that ultimately is returned by the original call to parse room.
Can you go back?
Yep.
I didn't know, what is that part? What are you on?
I'm in parse cave.
Okay. I thought you were adding stuff to parse room.
I did.
I lost that.
Parse room returns a room. That's all I changed with parse room.
That's it.
Yep.
And then in cave, what did you just add about seasons?
In parse cave, I created a brand new cave at the very top. And then at the bottom, well, I created a variable here for the entrance. I read in that entrance from the call to parse room. And then I ultimately set C's entrance to whatever the entrance was.
And see that.
And at the very, very bottom of parse cave, we ultimately need to return C, because parse cave is to return a cave. All right, so now we need to go down to parse room. Parse room needs to ultimately return a room. So now we need to go into our room objects and do something very similar. As it stands right now, our constructor for room does what? Well, it takes in the cave, and then it also takes in the depth of this particular guy. So it takes in all this information. But ultimately, it's going through and it's just generating whether or not this particular room has a treasure. It's then also generating whether this room has 0, 1, or 2 exits. All those things are being randomized. In our case, we don't randomize that stuff. In our case, we're going to build a blank room, we're going to set the treasure, and we're going to add some exits. Does that make sense? So we need to write a second constructor here for room. Public room. We'll have this guy take no parameters. We'll eventually probably pass it the cave and stuff, so it will work in our game. But for right now, let's just keep it simple. So we'll create a blank room. All right. And we'll set has treasure. We'll initialize this stuff. So we'll say this dot has treasure equal to false. So by default, there is no treasure. We'll say this dot the exits is equal to a new linked list of rooms. And for right now, we'll say this dot the cave is equal to null. And this dot my depth is equal to 0. We're not going to use the cave or the depth for right now. We'll go in and add that functionality here once we actually want to play the game with it. But initially, we're just going to deal with being able to walk through there. All right, so that's a blank room. Now we should be able to set the treasure for a room. Okay, I don't think we have methods for any of that. We do not. Good. Okay, so we'll just do it all right here under the constructor. So because of the way our JSON is working, we are reading in whether or not it has a treasure. So we're going to have a public void set treasure equal to Now we're reading in the treasure as a true-false value, correct? Okay, but we're going to go ahead and have set treasure come in as a Boolean, and we'll do the conversion inside of our Json parser. So Boolean B, and we'll say this dot has treasure equal to B. Okay, now before we go any farther, let's go ahead and start seeing these objects in action. So we want to go into our JSON, go into parse room. The very first thing we'll do in parse room is we'll create a blank room. As soon as we read in a treasure, we'll set that treasure value for that room. That make sense? So we'll come into JSON Parser. We're in parse room. Very first thing we do in parse room is we create a room R is equal to a new room, calling the blank constructor for room, the one we just wrote. Okay? Inside of the variables, if we read in a variable for treasure, we have treasure value right here as a string, either true or false. We're going to say r dot set treasure, and this guy takes in a Boolean. So we'll say if treasure value dot equals true, we'll set the treasure to true. Else r dot set treasure to false. For this particular room that we're building right now. Notice that every single time we call parse room, we will build a brand new room. Because what does parse room do? It returns a room. Okay.
Wait. R screen appears like. Wait. Why is my R right underlined? Yours is.
Because did you do this at the very beginning of parse room?
Yes, but I typed it wrong.
All right. Now, so this is what we do when we find a treasure. We set the current room that we're building's treasure equal to this. Now, if we find a room, what do? Well, we want to parse that room, but this guy's ultimately going to boil down to a room. What are we going to do with that room? R dot, we need to add that room to this room. So we need to go back into room. We need to add another feature, just like we have set treasure, public void add room. This guy will take a room R as a parameter, and we'll say this dot the exits dot add R. This will add another room to this particular room. Add an exit to this room. Okay, so we wrote a little method in here for room. Add room. Back at our JSON parser now. If we see a variable of type room, what do? We call parse room. What does parse room return? Parse room returns a room. What do I want to do with that? I want to add it to the room I'm in the middle of building. So I'll say r dot add room, whatever is returned by this dot parse room. And that's what will happen over and over again as we spin through this loop for as many variables are in this particular room. Every time we find a treasure, which logically should only be once in there, but hey, if you want to create 5 treasure variables, we'll just keep flipping it on or off or whatever. But you can have as many rooms as you want to have. Our version of this game says you either have 0, 1, or 2 rooms, but our JSON doesn't have a limitation to that. We could literally put 10,000 rooms in there. It would be just fine. That makes sense? Okay. So Every single time we run into a room variable, we will parse that room. Parsing a room ultimately returns a room object. What will we do with that room object? We'll add it to the room we're in the middle of building. At the very end, when we're done parsing that room, after we've done all of our cur pos to new positions and stuff, we will go ahead and return R. That is, return the room we just built. That makes sense? So every single time we call parse room, we're going to build a room and ultimately return that new room that we built. The first guy that called parse room did what? That was parse cave. And what did parse cave do? It built a brand new cave. Ultimately, it set that cave's entrance to whatever's returned by the original call to parse room. Okay, now let's think about our game. What does our game do? Well, our game sets a current size and a current level, and it sets our current cave. Well, if we want to create a brand new game using a JSON file, we might say, have a constructor for game, public game. We do it out in driver, I think. I'm going to give it the full path for that. So our game is going to take in a string JSON path as a parameter, and he's going to create a new JSON parser. The JSON parser is going to do what? The constructor for JSON parser takes in that file name. So inside my game, I'll say JSON parser JP is equal to a new JSON parser, whatever JSON path you passed in. That's what we'll use to build it. And then we'll say this dot cur cave is equal to jp dot parse cave. And then we can go ahead and set the initial variables of stuff to whatever. So we'll just set this dot cur level equal to 1, and then this dot cur cave size equal to we'll say -1 for a generated cave. Okay. So our stats are not getting updated with this one, because our stats originally got updated as we grew our cave. In this case, we're giving it the cave. So we might have to provide it stats at the beginning to get everything set initially. We'll see that here in a few minutes. Okay, but for right now, we'll just zero everything out. Okay. So to build a game with a JSON file instead of a random cave, we'll pass the game our JSON path. That guy will then create an instance of our JSON parser, passing that JSON path. The cave for this game will be equal to whatever cave is returned by our parser's parse cave method. And then cur level, cur cave size, we just give some default values. Okay? Now, out here in driver, when we create our game, we're going to use the second version of our constructor. That is the constructor that takes in a path to the JSON file. Then we'll start that game. So that's my driver now. We start the game, it'll read in the JSON file, it'll create our cave room structure. Then when we start our game, we should be in the cave associated with our game. Where things start breaking, because remember I said you can have your game crash. Where things start breaking is the fact that none of our stats are set to anything. Does that make sense? So what we'll do, just for sanity's sake right now, we're going to go ahead and we're going to set, I'm going to default those variables to what they should be. So we have what? 1, 2, 3, 4, 5 total rooms, correct?
Mm-hmm.
So we have 5 rooms,
2 treasure.
2 treasure. Okay, let's do
What's
with
the,
them.
wait, what's the error if you don't do the?
If I don't do that, I think your game will be over right off the bat. Yeah.
Then I've got a 10-point.
Well, hold on. While these numbers are fresh in my head, let me do them. Then we can go back to yours. I already lost my
5.
numbers. 5 rooms, 2 treasures.
Yes.
Okay, so in our game, we'll say stats dot. What is it? Set. All right, let's do stats dot reset. Then do we have a stats dot? Well, I guess we'll just call add treasure twice. We're hacking this anyways. So we're gonna call add treasure twice. That's our 2 treasures. Then we had 5 rooms.
5 rooms.
Okay. Stats dot add room. Call that 4 more times. 3.
And 3 more false. No.
Oh, we have 2 treasures. We have 5 rooms. Then we need to have a stats dot.
Treasure.
No, that should be fine. So when we play, I think it gives us our number of. Okay. Yeah, so the cur length thing, that's all thrown off because of the, well, no, that's fine. Moves remain is 11 because we have 5 rooms, right? So we have 2 treasures remaining. So here we are in our original room. So we have just entered this room.
And there's a treasure.
Okay, that room has 1 exit, 2 exits.
0.
And the room we're in has a treasure. So we notice that we do have a treasure in this first room, and we have 2 exits. Okay? Again, where do those 2 exits come from? Here is the first room, that is an exit inside of our main room, and here is the second room, that's an exit inside of our main room. So if we went to exit 1, the second room, we would see no treasure and no exits, assuming this got built correctly. Let's go to that one first. So we'll go to 1. No treasure, no exits. So now we'll go back to the beginning. Crashes, blah, blah, blah. Run this one more time. Take us back into that first room. If we go to room 0, what will happen?
3 rooms.
Room 0 has 1 exit. There's room 0. Room 0 has a single exit in it.
No.
Okay, so here's room 0, that whole thing, right? Room 0 has no treasure and has 1 exit. There's that exit. That exit has a treasure and has 1 exit. That exit has no treasure and no exits. That make sense? So if I say go to room 0, I see I have no treasure and I have 1 exit, 0. If I go in there, again, I hit the end of it. That's where the crash comes in. 1 exit. I found the treasure. It crashed out because I didn't have the cave, so it tried to load me into the next version of the cave, and I didn't give it access to the cave. That's why it gave me the null pointer exception, because I never gave it a cave.
Can you go back into room?
back into room. This is all we added to room, just these three.
Yeah, mine's got.
Kind of slow here.
There. Okay, got it.
Good? All right. So now we're building an object version of our cave. So that's the end of the homework assignment. You have a program that's allowed to crash, all that crap, but it literally builds a cave with rooms in it. Okay? Now, hopefully you noticed after we parsed the JSON, after we wrote the thing of splitting apart the data that was being communicated, creating the objects actually wasn't that difficult. Right? We had the pieces. We just had to build a couple of constructors. Well, now we need to go back and look at how rooms were initially built. Here's our initial way a room was built, where we pass it a cave. So every single room knows about the cave that it was in. A room also knew about its depth. How do we use depth? Remind me how we used depth. Well, we have stats. We're setting the depth, a max depth. Maybe we were using depth to try to create a map?
Yeah.
Is that it?
To create the map.
Okay.
We were trying to make X's.
Okay, so depth is really never used in our current version of the game, but the cave is used. So what we'll do, just to prevent it from crashing for right now, we're going to say our current, let's see, what am I doing? We need to give it the, when we build a room, even our generic room here needs to have access to the cave. So we're going to have this guy take in a cave, the cave, and we'll set, this is our brand new room constructor. This is the one we built a few minutes ago that took no parameters. Now we're going to have it take in the cave that it's being added to. And we'll set the cave equal to that. That's where our null pointer exception was coming from, was we didn't have access to the cave for the next cave to be built. Okay?
Are you going to Json Parser? Oh, do you? Sorry, just
What do you want to see in here?
just keep scrolling, but not fast. Okay. Parser. Oh, your room's the same error.
Yeah, I haven't passed it the cave yet. Yeah, our room, we just changed the constructor so that this guy now expects a cave. So I have to give it the cave, which means that when I'm inside of Park's room, I need to have access to the cave. What cave? The cave that I built inside of Parse Cave. The problem is, as it is right now, the cave I built inside of Parse Cave is a local variable to Parse Cave. So what I'm going to do is I'm going to make it a global variable. Private cave C, we'll put it up there at the top level. And then instead of redefining it here in parse cave, we'll just give it its value. We'll say C is equal to the new cave.
This.c or just C?
Well, this.c is correct, so C, but that's probably the way I've been telling you to write it, like that. Okay? Now, we built our cave here, but now it's accessible globally. So inside of parse room, when we create our brand new room, we now have access to the cave that we lived in through this .c. Does that make sense? We made it globally available so that every single time we built a brand new room, we could go ahead and pass it a pointer to that cave. So now we'll run this. And we'll go ahead, we'll go to exit 0. We'll go to exit 0. We're a winner. Now it generated a brand new cave for us of size 3 with 5 moves remaining. Because the default max size was it 2? I think initially. Point is, it didn't crash because we had access to the cave. Okay, but right now our code gives us kind of this hodgepodge type of experience. That is, it is giving us we can read in one JSON file and traverse that cave. But at the end of that cave, it's going to go on to the next cave, and it's going to generate that cave for us. Eventually, what we would like to do is we'd like to create many caves inside of a JSON file. For instance, you might have the JSON file be the collection of all the caves in the game. That make sense? Might have it be the collection of every single cave in the game. In order to do that, we then need to modify our game. Because right now our game is saying when you beat one cave, go and generate the next cave. Well, how would that change? Well, what would change is if I'm going to go and generate the next cave, well, I need to now not generate a cave, but I need to move on to the next cave that was listed inside the JSON file. Make sense? So if we were to change that, we go into our JSON file here, and I'm going to copy all that. Okay, but now I'm going to go up a level. This thing is no longer a list of, this guy is no longer a cave. He is now a list of caves. So that means that this guy would look like this.
So you want to make cave 1, cave 2, cave 3?
So let's just say this guy had 2 caves in it. And I'm going to dumb down our second cave so it's different than our first one.
I just want to change the treasures.
We'll just make the second one literally be a cave with no rooms in it. Well, every cave has an entrance.
Okay, no.
Right? This is the entrance. It has a treasure, and there's no more exits.
Small cave.
Correct. Okay, so now this file, our JSON file, is now a collection of caves instead of it being one cave. Go in that. And we're comma there. Okay. So now this guy has 2 caves in it. So no longer is this a JSON file containing the definition of a cave. It's a JSON file containing the definition for a collection of caves. In this particular case, we have 2 caves. Okay? Here's the first cave. That guy all the way down to here. That's cave 1. Cave 2 is this guy all the way down to here. Much simpler cave. Cave 2 is a much, much simpler cave, right? Okay. Now, if we had to go in and modify our JSON parser to support this new cave, this new JSON format, where it's no longer a cave, it's now a collection of caves, what would we change? Well, here's our JSON parser here. This guy currently has a cave called C at the top. I'm actually going to rename that real quick. I'm going to right click on it. I'm going to say refactor rename. That way it'll change it into all the other places where I'm using C. And I'm going to call this cur cave. Because now our JSON parser might be working on multiple caves. So at any point in time, we're going to have a cur cave. So all refactoring did is it allowed me to change the name here, and then all other places I used it, it automatically changed the name for me. That's what refactoring does. It's a software engineering term. It's literally equivalent to you changing it up top and then going through every place else and changing it by hand. Okay, so here's our JSON parser. Inside game, what are we doing? We're saying, where's my constructor for this guy in game? Here's my JSON path. We're creating our new JSON parser, and then we're saying cur cave is equal to parse cave. I no longer want it to do this. I expect my JSON parser to return a linked list of caves for me. Correct? Because now I have 2 caves. So I'm going to go ahead, we're going to add another method to JSON parser, maybe just called parse. And this guy is going to return a linked list of caves. Okay, so we call parse. So we're going to create a linked list of caves called the caves. And this guy will be equal to a new linked list of caves. That's currently empty. And we're going to say while cur pos is less than this dot JSON dot length, as long as we still have crap left to read. As long as we still have crap left to read, what are we going to do? Well, we're going to say the caves dot add this dot parse cave. And what will happen there? It's going to go into parse cave. Let me do this here real quick. It'll come in here. We'll go to our first cave. But right now, the way we handle our cave is we find the variable for cave. correct? The variable for cave, before our parse cave started there. We need to get past this, just like we did in our original variable. So we need to find the first variable, which should be a cave. That'll leave us right here. Once we see it's a cave, which it always will be, then we can call parse cave on the rest. Does that make sense? So we'll say this dot find next variable name. We know this is going to be cave, right? It should find two caves here. We'll go ahead and read it in.
Yeah.
String var name is equal to that. You know, we can then say if var name is equal to cave, do this. If var name is equal to room, do this. But it's a cave. Okay, if we're at this level, it's going to be a cave. So we'll get our var name, and then we're just going to say parse cave for the value. Okay, we'll do that over and over and over again. Ultimately, we will return the caves. So this loop, when we say parse for our JSON parser, it's going to go through, it's going to build us a blank link list for caves, capable of holding caves, and we'll go through and we will build each of our caves and ultimately return the linked list of caves. Now, because we have it set up here for cur cave, being the cur cave that we're building, notice that every time we parse cave, we redefine cur cave to a new cave. That way, the rooms underneath that particular cave will be linked to that cave, not the other cave. Okay? So, at this point, why don't we go ahead and say this. I'll do a little system.out.println found cave. So when we call parse, we should see found cave print out twice. Does that make sense? So I'm going to go into game. And instead of saying parse cave, like we're doing now, I'm going to go ahead and say jp.parse. I won't do anything with it yet, but we should see two caves. Found two caves. Oh, hold on. We're dying. Do we never... I think we're not finishing our cave correctly. We hit the end of our first cave, so that... Oops, sorry. Here's the end of our cave. So we move past that closing curly brace. Do I move past it? I'm pretty sure I do. The end of parse cave.
And then it asks you to keep looking for another, it just wants you to keep going until it finds something. While it's not an end curly brace, it's going to keep going until it'll take in cave. And
Right, but I'm moving past it. So I'm finding the closing curly brace, which is there. This is the end of cave. Then I'm moving past that. So the very first time through, it should set me right here. I'm sorry, it should set me right here. Then I'm ultimately returning that cave. Okay? So that's going to return it back to parse. This guy. So I just read in that cave. Spin back up. Is cur pause less than JSON's length? Should be the very first time, because cur pause is only progressed up to that midway point, let's say. So we'll go in, we'll say found cave again, then read it in. So it's got to be...
Can you go back to
Oh, I know the problem. The problem is because we added an extra set of curly braces, which is correct. Here at the very end, when we read that second cave, the cave ended right here. But I still have another. So the guy will not be the same length because I still have another curly brace to hit. So we need to do while there's no more variables. I should have used my own. This is just poor programming. Me trying to do this based on curpause. So I need to say while this dot has more variables, do that. Found cave, finished cave. Here's our first call to it. Is my XML or is my JSON bad?
I messed up because that didn't give me an error.
Mine's currently giving me an error, so let me fix mine, and then we can fix it. Then we can fix yours, unless you want to turn yours into a broken set too. All right. Cave set, cave, open curly brace, room. All that should be good. Here's the end of that cave right here.
You're not closing one of those.
This guy closes, this guy closes, this guy closes. Open, close, this guy closes that, this guy closes that. I think those all close.
Do you need to like reset curpause before going to the next cave or something?
No, because we want curpause sitting right here.
Right. Okay.
And then we're going to say find the next variable. This guy does have a next variable.
The way mine came up on here is it found the first cave, and then it finished it, and it gave me curpause is 152 and length is 211.
Oh, we have an error. I have an error in my code.
Oh, but then
My XML here is broken.
But then mine did the exact same thing. It started another cave, finished cave at 152, 211, and then it said game over and everything's done. So it counted the first cave twice. That's kind of weird.
This is the problem. I have a comma here when there's actually no more variables. Because I cut down my second cave, I deleted a bunch of stuff, I forgot to get rid of that comma. To let me know that I'm actually done with this room, which lets me know I'm actually done with this cave, which lets me know I'm actually done with the whole thing. Okay.
Mine's still just counting the first cave twice.
Let me think. This will be a good way of, I'm going to, after I found a cave and finished parsing it, I'm going to do a,
Now I got the same errors here.
I'm going to do this. Found cave concatenated with, put a little arrow in there. This dot JSON dot substring curpause. So show me where we're currently at in the in JSON all the way to the end. So here's my cave. We're at the very, very, very beginning. Oh, wait, is that actually the first problem? No, it's not. It'll just move me to the first variable. That's fine. So that shows me the entire thing. Then, where is it actually dying? It's dying at, oh. I don't want to start my game yet. Okay, so found that. Started cave, finished cave. Curpause is that. Go into Json Parser. At the end of parse cave, I return the cave after I print out this curpause stuff. So I return cave. That comes right here. I add that cave. Then I spin back up to this while loop while this has more variables. Let me print out this. Finished cave. Let me print out everything where it's left. It should be right at the beginning of our second cave. Okay, so it finished cave. So we're stuck.
No cave. There's no cave.
Yeah, there is no cave. What the heck? Just into my room. So I have this, then this. So it's sitting there, which is the end of our cave. Is that right? Oh, that's the end of the room. This is the end of the cave. But it's sitting right here. I'm not moving far enough past. One, two, three, four, 5. 4, 3, 2, 3, 2, 1, 0. Okay, I have the correct number of curly braces there. Move to the closing curly brace for this cave. That's there. Move past it. That's there. So it just moved me to here. No, it moved me past here, this end room. So does that mean room is not accurately moving past the end of it? Because it's leaving me right here. I really need it to be right here. Let's look at the end of parse room. Move to the closing curly brace for this room. Move past that. That should be fine. It's really leading me to believe that my code is questionable here.
It's opening cave.
This is opening cave list. Here's our cave. Opening value for that cave. Room. Opening room. Treasure. Room. Opening room. Treasure. Room. Opening room. Treasure. Room. Opening room. Treasure. Close room. Close room. Close room. The comma tells us we have a second room. Room. Opening room. Treasure. Close room. This closes that room. This closes that cave.
We're not closing cave.
We are right here.
I know.
Curve pos is 236. I have 382. Oh, wait a minute. That's showing me what the string looks like. So this is room, treasure equals false. But it doesn't have the word cave there. Huh? Oh. No, we're way back. The next cave should be here. This is showing me where it left off the end of the previous cave. This has to be a problem with room. So we hit a room, begin parsing the room, and let's, because we're printing that out. Starting cave, finishing cave. Actually, we never say parsing room. So we never actually finish parsing the room. I think that's the problem. Okay. I think we're okay here. We just because we made it a list of caves instead of just a cave, we kind of broke stuff. So to initially start parsing, we first need to move past the opening curly brace. So just like we did with parse cave, get to, I'm going to do that. So inside of parse, I'm inside of parse. We need to get to the beginning of first cave.
Where'd you copy that from?
The top of the old parse cave. But it's just 2 lines of code.
And then where are you?
I'm in parse. So we need to move to the beginning of our first cave. That means we're going to walk until we finally hit our opening curly brace. That is the very first curly brace in this file. We walked past this guy. Then we kicked it forward 1 space. So that's what all this does. That code right there moves us into position in our JSON file so that we're sitting before that line, right there. Then, as long as we have more variables, we're going to do something. We'll find the next variable, cave, takes us here. Then we need to get to its value. What do we do at the beginning of parse cave? So as long as we have more variables, which we will the very first time, we'll get the variable. This should be cave. You print it out. System.out.println.
Can you go to, wait. Can you go to parse cave versus what's that?
Yeah.
Okay, wait, stop. Okay, scroll up like 3 lines worth of scroll. Okay, a little bit more. 3 more lines. 3 more lines. No, 2 more lines. No, down. Okay, I've got it. No, it's just 1 more line, please. I've got it. I know it's wrong.
This one?
Yes, see there, perfect. See, you're in, not mine. In your you're in your parse itself, like, so you find X variable name, and then it does that stuff, and then it does the caves add this parse cave. But every time you go into parse cave, see the bottom this line is curpos equals 0, so you're going back to curpos equals 0.
Correct.
But like then every time you're adding a new cave.
No, I mean you're right. That's the problem we have.
But,
Because we're resetting it.
yeah.
You're right. That is our problem.
But then, no, but that's not, just forget it. It's like, but why is it only doing it twice? It keeps going back to 0, it shouldn't only, on mine it counts the first cave twice, and it shouldn't do that.
It's because we forgot to set it to 0 to begin with.
Yeah, but why?
So I'm going to take this out of here. We're not going to do it inside of parse cave. Well, wait till you correct yours like mine and then see if yours works the same way.
Sure.
So the issue we were running into is here in parse cave, we are always resetting cur pos to 0, which is extremely problematic since we have multiple caves in our code. We want at the very beginning of parse to set cur pos to 0. Always start at the beginning of the JSON file, right? Then we walk past the beginning of our opening curly brace for our cave list. Then, as long as we have more caves, read in the variable name for cave. We'll go ahead and print it out, proving that we read in a cave. Then we'll call parse cave. Parse cave then creates a brand new cave. We're going to say starting cave. It'll move past the opening curly brace for that cave. Okay? Now keep in mind that we just moved past that. So we're sitting here. Then we move past that. So we're sitting here. Now it's going to move past the opening curly brace for that cave, which puts us right here, which is the same place we were in before. We'll move one forward. Now we read in our room, so on and so forth. Okay? So now, red variable cave, here's all of our parsing stuff. Red variable cave, here's all of our parsing stuff. Finished cave. So it did both caves.
I still kind of because cur pos is less, but then
It was one less. So I think the one thing we're not doing now is at the very end of parse. The very end of parse here, we need to walk past the closing. The same thing we did at the end of parse cave before, just for those lines from the end of parse cave. I'm going to take those, copy them, and we're going to put it to the end of parse. Again, this is just for completeness. So we're going to move to the closing curly brace of this cave list. And then we'll move past that. And if we want to see our final stats, I'll actually steal that line that says cur pos, and let's just do that at the very end. So I took it out of parse cave, and we'll paste it into parse right before we return the caves. And we should see that cur pos is the same as length. Proving that we've literally walked the entire file without resetting ourselves in the middle. So the short answer is you found our error. Our error was that we continued to reset cur pos. I received a Bitcoin payment.
Oh, nice.
I just got a text message letting me know I received a Bitcoin payment. So now, and I know you're still looking for an error, but let me just show the consequence of this. So now our JSON parser, that is parse specifically, is returning a linked list of caves. If I go into game, we have our JSON path, cur cave, here just for the time being, inside of game I'm going to create a linked, let me actually do this globally. So I'm going to create a private linked list of caves called the caves. All right, and I have to import java.util for a linked list. So this is a variable that I'll have as part of game, and we will set the caves. This dot the caves equal to whatever parse returns. which should be our linked list of caves that it read from our JSON file. Okay? Now, just to kind of see that we read in both caves, sorry. Hello. For cur cave, this guy right here, I'm going to set him equal to this dot the caves dot get 0. So we'll set it to the first cave we read in, which should look exactly like the original cave we did when we read in the JSON. Okay? Then we'll run it again and we'll set it to cave 1, which should be our mostly empty cave. Okay? So we'll run this real quick. I have to go back out to driver and uncomment out the start, because that was causing us the error before because I didn't have a cave. Okay, so when we create our game with JSON, we're going to get our linked list of caves, and then we'll go ahead and say our game's cur cave is going to be that very first cave. So when I run this, I have the cave with 2 exits. We'll go to 0. There should be a dead end. So no treasure, no exits. Well, actually, hold on. Oh, I need to go to room 1 as our dead end. Let me just go back to the beginning here. Because my stat. Okay. Room 1 is our dead end. So if I go into 1, we have no treasure, no exits. Go back to the beginning. Now I can go to room 0. Notice that our treasure is now gone in the original room because we picked it up. Now I'll go to room 0 and we have no treasure. Obviously exits are 0. I'll go to 0. We get our last treasure. We beat that one. Make sense? Okay, so that's the original cave we read in. But now I say, what if I want to play cave 2 instead of cave 0? This should be the incredibly boring cave containing 1 room and no treasure.
Right away.
It'll be a very boring cave. Okay? So we'll go ahead and call that guy. No treasure, no exits. KK, thanks. It didn't say winner right away because we didn't reset the stats. We forced our stats down here. Remember, we added treasure twice. So this guy still thinks we have a bunch of rooms and some treasures because we set our stats like this.
Okay.
That make sense?
Even though we add treasure for this room, so it counts still 1 or 2 rooms.
Well, because we hard-coded this.
Can you go back into Json Parser and go to parse?
Okay.
And then
There's parse.
Wait, didn't you have? Wasn't there something that said what's the use of string var name equals this dot find next variable name?
Nothing.
Then why doesn't yours come up yellow? Mine does. Yellow and
Well, because I'm probably printing it. You're probably not. You probably don't have this line.
so can we delete it then?
Well,
Is it useful?
you still need this part. You need to move to the variable name. We just happen to know it'll always be cave in here. I was just printing it out, proving it was cave. You don't have to store it, so you can choose to do that.
Okay.
And by not storing it, now we can't print it. So we can choose to do that.
Okay.
So now we're just utilizing our find next variable name to move us past that variable name.
Gotcha.
Because we know it's cave. And this will work the same. Okay, similarly, we don't need this substring thing anymore. This was just proving we were trying to figure out where our problem was. So you don't need this last line in here either. So ultimately, this while loop just goes through each of our two caves.
So now, do we have something where we can generate a cave and have it printed in JSON form?
Ah. She just assigned you your homework assignment.
Oh. Was that really what you were planning on?
It was.
Oh.
You could still hate her. No, that's the next homework assignment. And I'll give you this as a starting point. But the reality is, it should be substantially easier than this assignment was. We're going the other direction. This assignment was take JSON and turn it into objects. Well, what did we have to do? We had to write the whole, we wrote most of a generic JSON parser. Everything but dealing with arrays. I mean, what we wrote today is something that could just go and be built into Java now. We wrote a generic JSON parser. Just happened to be in terms of caves and rooms and treasures. Okay? Where we could just switch this out and a variable name is a variable name, right? That's our find next variable name. I could put 40 different kinds of variables and names in there and find next variable will move past each one, right? Well, what we're going to do for our next homework, is we're going to add methods to Cave to export it as JSON. Does that make sense? So here, I'll go ahead and we'll put that assignment in here, and then we'll also talk about our paper. Might actually finish a few minutes early. Very unlike me. I'll try to babble. All right, so homework number 6. And just so I don't forget, let me, so I'll save, let me go zip this code up real quick, please. It's crawler. Okay, so I'll move that to trash. Zip that. That's our new one. Okay. Correct. Just double check this. Yeah, that's the new one. Okay. So, modify the attached code to include a export to JSON method within Cave, within the Cave object. This method should output the JSON version of our Cave, which should be identical to the JSON within cave.dat for that particular cave. Remember, right now our cave.dat is a collection of caves. I'm not asking you to export a collection of caves. I'm asking you just to add to just the cave object, export yourself as JSON.
So we're not exporting randomly generated ones, we're just exporting...
Well, you're exporting anything that is a cave, which means that a randomly generated one should also work. Anything that's a cave should be able to export itself as JSON. But you don't have to export a JSON, a cave collection, just a cave. So every single cave object should have a method called export to JSON. So for example, right now I'm using, cave 1, the simple cave. Okay, I'm using the very simple cave here. For that particular cave, export to JSON should return that with one additional opening curly brace before it.
So it
Well,
should-
actually, it should return this. That's what it should return. What I have highlighted there. That's exactly what it should return right now. The value of that cave in JSON. So that's what cave 1 is. Cave at bucket 0, it's a little bit more complicated cave. He should return that. Does that make sense?
Oh, print it, right?
Yeah, you can just print it out to the screen. That's fine. But it should create that string. It might not be formatted as nice. It might be all on one line because you're going to be concatenating stuff together. But it should ultimately contain that.
We're not actually exporting it into a document.
Yeah, you're not writing into a file or anything. You're just teaching a cave how to turn itself into JSON and spitting it to the screen. Yep, no storage or anything. Just you're reversing what we just did in class today. You're going the other direction. But what's nice about it now is, as she pointed out, this should work on randomly generated caves. Why?
So it's not doing it while it's generating the cave, it's doing it once it's done?
Correct. You should be able to ask a cave to export itself as JSON.
Okay.
And it will walk through that cave, entering every room, creating itself as JSON. As a hint, you are going to have to add methods to room as well to export it, for a room to export itself as JSON. Does that make sense? A room needs to know how to export itself as JSON as well, because what's a cave? A cave is a room that has a collection of rooms in it. So by having those methods all work together, you'll be able to get one big long string that is the JSON equivalent of a cave. Make sense? What I'm asking you to do? All right. And then I'll attach the code. Crawler.zip. And Lauren, do you need me to email it to you, or is yours in the right position?
I think it's working.
Okay. Okay, so we meet on the 5th, so that's due then. New assignment. Okay, now report number 6. Write a 2 to 3 page paper discussing threads versus processes what is a thread, what is a process, how are they different, how are they the same, what types of problems lend themselves to threads, what types of problems lend themselves to processes. Is one better than the other? Why or why not? Make sense? Okay, so remember last class we started looking at threads a little bit at the end of class? I think we did that, right?
Yeah.
Is that in here? Just like the last 20 minutes of class, I think.
30.
Okay, so we're taking that introduction. We looked at it in code. So I did explain a little bit about threads, but now I'm going to ask you to look at the other side of the coin. Threads were born out of a need for something different than something called a process. Okay? So you'll investigate the difference between threads and processes and find out what they each do, how they're different, how they're the same, what kinds of problems lend themselves to each, that kind of stuff. Make sense? Okay. All right, questions, comments, concerns, bribes. Okay, 15 minutes early, look at that. I'll see everybody next Monday.